All right, today we're going to get into the really cool stuff, the hidden architecture that takes a bunch of powerful AI models and actually turns them into a single intelligent system. Let's dive right in.
Hooking up a single LLM to your app, something like GPT-4, it's gotten pretty easy, right? But what happens when you want to get more ambitious? What happens when you need 5 models, or even 10? Maybe you want to use the absolute best tool for every single job.
Well, things get messy, fast. All of a sudden, you're dealing with totally different APIs, different ways to authenticate, different data formats, and your once beautiful, clean code starts to look like a giant bowl of spaghetti. It's just a nightmare to maintain, and forget about trying to scale it.
So, how do we clean up this mess? Well, the very first step is to build something you can think of as a universal translator for all your AI models. This is the bedrock of a smart system, a unified interface. And that brings us to this core idea, model abstraction. See, instead of your app trying to speak 10 different languages to 10 different models, it just makes one simple, standardized call to this abstraction layer. And then that layer does all the dirty work, all the messy translation behind the scenes. And this right here shows you the difference perfectly. On the left, you've got the before, that tangled chaos of direct calls we talked about. But look at the after on the right. It's just so much cleaner. Your app's code is simple again, and now you can swap models in and out, or even add brand new ones without having to rewrite everything. It is a total game changer for flexibility. Okay, so now that we have this really clean way to talk to any model we want, we can get even smarter. We can add a layer of intelligence right on top, and that's where the smart routing engine comes in. I absolutely love this analogy because it just hits the nail on the head, right? Using your most powerful, most expensive AI model for every simple little task, that's like firing up a massive V8 engine just to drive down the block to grab some milk. It's complete overkill and it's super wasteful. Smart routing is all about picking the right engine for the journey.
And here's what that looks like in the real world. A simple request comes in, something like, hey, summarize this email for me. The smart router sees that and sends it to a fast, cheap model. But then a much more complex task arrives, like generate a deep financial analysis. The router instantly knows to send that one to your big, powerful, top-tier model. The best part? Your application has no idea any of this is happening. The router just makes the smart choice every single time.
So what's the payoff for all this? Well, it's huge. You're not just organizing your code, you're seriously optimizing your entire operation. We're talking dramatically lower costs, way faster response times for your users, and you get peace of mind knowing you're always using the best possible AI for your most critical jobs.
But a smart system isn't just about being clever. It's also got to be tough. It needs a good set of armor. So let's talk about how to build for the real world, focusing on reliability and performance.
This is one of those fundamental truths in tech, and it's especially true when you're relying on outside services. An API is going to fail. It's just a fact. It could go down, get overloaded, or just spit back an error. You absolutely have to plan for it.
And here's how a good system handles it. The system sends a request to your primary model, Model A. But whoops, it fails. Now, instead of just giving up and showing an error, it automatically tries again. When that still doesn't work, it seamlessly falls back to a different option, Model B. And success! The request goes through. Your user? They never even had a clue there was a problem. That's what a resilient system looks like.
So our reliability is locked in. That's awesome. But we can still squeeze out more performance and make our system even more cost-effective. The trick is to stop doing the same work over and over again.
And the secret weapon for that is caching. I mean, think about it. If 10 different people all ask the exact same question, why would you pay an expensive AI to generate that same answer 10 separate times? A smart caching strategy just stores the result after the first request and then serves that saved answer instantly to everyone else.
And the impact of this is just massive. With a good cache in place, something like 95% of repeat questions can be answered instantly for practically zero cost. If your app gets a lot of the same kinds of requests, this one feature can save you a fortune and make the whole experience feel incredibly fast for your users.
Okay, so let's bring this all home. We've talked about a unified interface, smart routing, fallbacks, and caching. When you put all of these pieces together, you're not just using AI models anymore. You are building a genuine, resilient AI platform. This table really sums up the whole story. Each feature we've gone over isn't just some random technical detail. It translates directly into a real-world strength, from simpler code and lower costs, all the way to rock-solid reliability and a much better user experience.
Every single piece has a clear and powerful purpose.
And this really is the main thing to remember. These architectural patterns, they aren't just nice-to-haves. They are the absolute essential building blocks you need for any serious AI application that's meant to be scalable, reliable, and actually cost-effective in the long run.
So I'll just leave you with this one question to think about. It's easy to be amazed by the power of a single AI model. But the real challenge, and honestly, the real opportunity, is to build a system around it that's every bit as intelligent. Thanks for tuning in.